Hey everyone, it's Hugo Bown Anderson here. I'm so excited to be here today with LLM hacker and machine learning connoisseur, engineer, and expert extraordinaire Hamel Husain. And we're going to have a very special guest join today as well to talk about data and DevOps tools for evaluating and productionizing LLMs, diving into a particular workflow and a particular product that Hamel and colleagues are working on at the moment. We'll get started in a minute or two. I appreciate we're running 2 minutes late. But if you wouldn't mind introducing yourself in the chat on YouTube, that'd be super fun. Let us know where you're calling in from. And yes, Nina, we are about to get going in 1 minute. So introduce yourself in the chat and we'll get started. Thanks. All right, Hamel and Emil, why don't we turn our cameras on and let's jump in and get started. Hey there,
Maybe we
guys.
should also introduce Emil as well.
Definitely. We will. We'll introduce Emil in a minute. I just wanted to welcome everyone who's joining on this fine Saturday morning in Sydney. It's probably not Saturday, or it may not be Saturday where you are, but it's super close. I just wanted to say a few words to introduce Hamel, and then we can introduce Emil as well. Hamel is a machine learning engineer who loves building machine learning infrastructure tools. Leads and contributes to many popular open source machine learning packages, has over 20 years experience as a machine learning engineer. So did machine learning even before, it was such a mind capturing behemoth. He's been at, a lot of cool places like Airbnb and GitHub. And at GitHub, this is relevant. He led CodeSearchNet, which was a large language model back in like 2016, 2017 or something like that, which was a precursor to CoPilot. He's now the founder of Parlance Labs, a research and consultancy focused on LLMs, which is how he started working with Emil, who will get to introduce himself in a second. I will say Emil is an AI engineer at Rechat, which is a real estate CRM. So we'll be talking about all the work they do with the LLMs working in the real estate CRM. So LLM workflows tools, including prompt engineering, data quality checks, LLM evaluation for both human and synthetically generated prompts, creating a really cool human-centric UX in Shiny for Python, actually, for interacting with LLMs and their outputs, unit tests for LLM outputs, using all of these to fine-tune LLMs, in particular ChatGPT. And we may even get to training classifiers and reward classifiers using RLHF, which is reinforcement learning from human feedback. But Emil, maybe you could say a few words about yourself as well.
Absolutely. Thank you for having me, Hugo. My name is Emil. I'm the CTO at Rechat. And effectively, what we do at Rechat is, as you mentioned, is that we try to cater to real estate brokerages and agents. They're using a ton of different tools to get their work done, a lot of different softwares, but usually there are ancient softwares that don't talk to each other that well. So we try to integrate into one single super app, and that's effectively the idea behind our app. But the AI world opened a lot of possibilities for us because our app can do a lot of things. So thinking that, hey, if we could have an AI agent that can do all of the things that our app can do, that would be immensely useful to our users. So that's effectively how we entered this world of AI.
Amazing. That's wonderful context. Thank you. And just to set the scene, can you both see my screen?
Yes.
So I was chatting with Hamel yesterday, and we were preparing this live stream, and we were thinking about all the details and all the tools that are being used, and we decided to kind of come up with a figure to kind of think about the workflows that Hamel and Emil use, and to use this to set the scene for what we'll be talking about today. So I just wanted to give a brief kind of look at this. I mentioned all the things we'll be talking about today, but we're essentially talking about generating human and synthetic data in LLMs in order to improve models, and then the virtuous cycle of going back and redoing that after error correction, right? And all the things that happen in that, from logging traces to unit tests to evaluation and curation to user feedback and A/B tests to the reward model and the RLHF I mentioned, to prompt engineering, fine-tuning, all of these types of things. So this is kind of the mental model we want you to have of what we're walking through today. Hamel, Emil, is there anything you'd add to that from a high level?
Yeah, from a high level, so this is a good context. We won't actually be showing anything specifically about A/B testing or reward models, but we will be discussing when we show you the relevant tool that might touch that. We'll say, okay, like this is what the output of that tool will lead to, but that's still a work in progress. That we haven't built those out completely yet. And so that's why there's a dotted line. So I just want to point that out. If you're wondering why there's a dotted circles here.
Yeah, exactly. Great. So I think maybe it's time just to jump in, right? And get started with what exactly maybe Emil, you want to set some more context with what exactly you're working on. I don't know if you want to share your screen to do so, or
Yeah, sure. I'll go ahead and share my screen so I can show a little bit of what Lucy actually is and what it can do. And then we'll get a little bit more technical in terms of how we actually try to achieve what Lucy tries to achieve.
fantastic.
So if you don't mind me sharing, can you guys see the screen right now?
Yep. Marketing Center.
Okay. Okay, perfect. So this is our application, Rechat. I'm not gonna get into the app because it's really dedicated to real estate agents. It's not relevant to our context. But the idea behind it is that it can do a lot of things regarding your contacts, your calendar, your marketing, your transaction management, paperwork, blah, blah, blah. So a lot of functionality is baked into the application because it's a super app. So that's by the definition what it does, a lot of things. Lucy, however, is the AI assistant that we're building that you can see here. We can open it up. And as you can see here, we are in a debug mode, and we'll get to how this debug mode, what it does and how it helps us. But effectively, what you can do with Lucy is to communicate with it, but ask it to do things for you. We have in our debug mode, we also have a shortcut menu of the things that you can potentially ask Lucy to do. So I'm going to go ahead and ask it to do something. It's going to take some time because the difference between using Lucy comparing to something like ChatGPT is that Lucy can actually do things for you. ChatGPT, you can have conversations with it. It can tell you things, but by normal definition, it doesn't do anything. It just gives you information. But here, for example, as an agent, I can ask it to do something. For example, I can ask it to create me an email marketing, and it's going to go and create a whole email marketing for a specific listing of mine, which in the rest of the flow, I'm going to be able to share and send and whatnot, which I'm not going to go through because that's not in the context of the AI word that we're discussing right now. But there's a bunch of more things it can do. It can search for listings. It can send emails. It can do also a bunch of things. And the challenge for us at Rechat is to figure out how to make it smart to be able to do all of those things. Which sets up the stage for everything we're discussing here. Does that give you some context?
Oh, you're on mute, Hugo.
You're on mute.
Sorry, yeah, that's beautiful context, and I love that you've set the stage of ChatGPT is conversational, whereas this is an agent of sorts, and you've needed to figure out how to get it to actually do things, and also how to train it with domain expertise as well. And these are the types of things that we'll go into as well. And we already see in your, I presume, developer version of it, we have a Langsmith debug, which I presume is something we'll talk about a bit more soon. But having set that stage, yeah, let's jump in and see how it all works. And people who are here live, feel free to ask questions in the chat as well, and we'll try to get to as many as possible.
Yeah, absolutely. So this is the diagram that you already shared, and I think for the rest of this conversation, we are going to go back to this to show how things that we are showing is connected to this. But basically, as you can see, the LLM invocations, it all kind of start with a human, and this is exactly, for example, how we start with the debug mode. We have a QA team that goes on a day-to-day basis, tries to have conversations with Lucy, and tries to get it to do things, to see how it's responding, to evaluate it, to report more issues about it. And when that happens, this is effectively how we use Langsmith. We effectively use Langchain as the basis of this. So rather than connecting to ChatGPT, we use Langchain. It's been a huge catalyzer to our work. It's effectively creating a lot of abstractions and ideas that we had to think for ourselves to build, but by using Langchain, we're leveraging all the expertise that they've had and all the abstractions that they've come up with, and also all the tooling that they've come up with.
So yeah, and
Langsmith
maybe
is
you
one
could
of
just
them.
say a bit more around how, for people who don't know what Langchain and Langsmith are, what they are, or what the value prop is to you, because they're actually, Langchain has a huge amount of functionality, right? So why is it useful? What does it do?
Yeah, so Langchain has several different type of advantages for us. First one of them is that I see a lot of people that have tried to work with Langchain come on say, I don't need all these abstractions. Langchain does a lot of abstractions, but I'm just trying to call ChatGPT API. I don't know why I would need to use Langchain. If all you need to do is to make some API calls to ChatGPT and send some very basic prompts, Langchain is not for you. But if you're trying to build an actual language model application that is going to need to make different type of prompts, have different type of functionality, have different type of agents, have history, memory, and all these different type of things that people are going to need in an LLM world, then Langchain comes and becomes a catalyzer. Everything Langchain does, you can already do for yourself. But by leveraging Langchain effectively, first, you get everything that you want to do in a way that is abstracted away from you. So they have thought about it and they have come up with very nice abstractions. So that's number one thing. They have thought about this way more than you are going to. So you're going to set up your application beautifully and you're going to be able to connect the dots easily. The number two advantage of using that Langchain is that they have a lot of tooling being added, Langsmith being one of them. When we initially used Langchain, we loved it, but we were like, okay, but we need something to be able to log all the LLM conversations, to be able to dive into them, debug them, and get a better insight into it. And we were not even thinking that that's Langchain's job. We were thinking of building a tooling ourselves. But suddenly, Langsmith was dropped by the Langchain team, and overnight, we suddenly gained a huge amount of support in terms of how we dive into our insights into our application and how Lucy, our AI bot, is functioning. So the number two advantage is that their ecosystem is growing, Langchain's ecosystem is growing, and just by being a part of that community, we get access to all these tools and benefits that is upcoming from their work, which is continuously growing. So we are very happy with the adoption of Langchain.
Yeah, and what Emil is saying is like I find that very consistent across all my clients. Is like, a lot of people, they don't have ML, like a machine learning people on staff, and they're trying to get up to speed, and they're looking for frameworks to like help ease their transition into this like LLM world, and like they're using things like Langchain. So when Emil got help from me or hired me as a consultant to help him, like he was already using all of this stuff. Like he was like, Langchain was already built, plugged in. He had a basic, he had a basic version of Lucy already. So all of that was built without an ML engineer already. So that just gives you some context of like, okay, that like, the role that tool might play.
Amazing. So let's jump in and have a look at it. If you could just command plus your screen a bit so we can see, make the codes a bit larger, that'd be great. We have a great question from Marcus Eicher asking, did you fine tune a certain open source model? Now, this is something we'll get to, but correct me if I'm wrong. What we're going to do is show you the type of interactions and conversations you can have with Lucy that then you actually fine-tuned ChatGPT 3.5 Turbo on with. Is that correct? So I don't want to spoil the punchline too much, but that's what we'll get to, Marcus. All of these conversations that that we will see were then used to fine-tune ChatGPT.
What I will say about the open models is like the framework that we set up can be used to then train an open model. We're setting up the foundation for that, and we'll show you why that is.
And this is a key point, that you do want to future-proof. You don't necessarily, you want to reduce the future cost of potential migration costs of migrations, right? By having like plug and play components, and think about your governance boundary with respect to those. So yeah, let's jump. What are you showing us, Emil?
So what you're seeing is basically a piece of our code that actually is very relevant to what we discussed about Langchain. This is basically the core of how we hook things up. And some interesting things going on here is that, for example, Langchain came up with the self-healing capability in the framework. So what we use is OpenAI functions and their function calling capability. It doesn't work always perfectly. There's sometimes it makes mistakes. But Langchain has built-in self-healing capabilities just by passing this one parameter to Langchain and activating the self-healing capability. We managed to reduce and minimize a whole bunch of issues to close to zero. So this was possible without Langchain, obviously. Of course, we could have implemented all of those. But just by using Langchain, we had the access to this functionality with almost zero effort. It was just a matter of activating it. So this is the type of success that we're getting by using Langchain. They are implementing best practices that we could do ourselves, but it's just going to take much more time for us to do if we were to do it, if that makes sense.
And going back to the diagram, this is all in the spirit of logging traces and versioning stuff in particular?
So this is about this is the core of that does the actual production work. So if you talk to Lucy, it's not about only tracing. Like a real conversation with Lucy you're having, Lucy needs to make some function calls. It uses OpenAI to do that. OpenAI doesn't work perfectly, and Langchain manages to detect that case by default automatically. For example, if the schemas of JSON don't match, it's going to automatically detect that and send the prompt back to OpenAI, try to fix that JSON mistake, and return it back to the user. So it's all happens in production.
The LLM invocation part of that flowchart.
So
that's what this is. Is like what is driving that square.
Yeah. Okay. Fantastic. Cool. So then, as it work, do you want to jump into the logging traces and Langsmith stuff, or unit tests, or how do you? There's a fork in the road here. So where do you want to take this next?
I think we can
go ahead.
Yeah, I think maybe we can discuss logging traces a little bit, because that's also relevant to the Langchain conversation. So I think it's a little bit of a natural flow. This is exactly where we were scratching our head, and we're like, okay, we should be building a lot of logging and tracing capabilities, so we can dive into the data that we have to understand it a little bit better. And that's exactly where Langsmith came in. Activating Langsmith, it was just a matter of like minutes for us. Just you enter some key endpoint, API key endpoints and whatnot, and then it's activated, and it's automatically going to connect to your Langchain, and it's automatically going to capture all of the conversations that you're having with your language model. So that was a huge start for us, because we suddenly had this huge tool. I'm going to demo it a little bit maybe. So for example, for this conversation that I had, I can just, in the debug mode, I can just copy the URL and it creates a Langsmith URL directly to this chat room that I had. Obviously, this is only for the developers, but I can just click on it and take a good look into the prompts that have been executed on the language model. So I can see that this was the initial request from the user. This was the output, and then I can see step by step what happened. So my program first executed this prompt, which says you're an AI assistant named Rechat, blah blah blah. User is asking this, do this, and then language model asked me to make this function call. My program actually executed this function call, returned the result back to the language model, and then that language model decided to come up with this final answer to the user. I'm not going to dive into the details of what those prompts mean, and what not for now, maybe later. But effectively, we use Smith as a database to store all of our traces because it is created specifically to store prompts that we run. So it's a fantastic environment for storing your prompts, and it's just a database that we store every prompt in.
And just to kind of pause here for a second. So this notion of traces is not necessarily a new thing. So traces have been around for a long time in engineering as a way to like log sequences of events. It's like very common, you know, especially in like the DevOps world. You know, there's open standards like open telemetry and things like that where people can log traces. And so this is like kind of the same idea of like, hey, you know, language models, they have this sequence of events like when they're invocated, you want to log that. And so what we're trying to show here is like it's really important to log this information in some systematic way. You know, you don't have to use Langsmith, use something. There's other kinds of things out there. There's like an open telemetry like related project called Open LLMetry, which we can link to in the show notes later. But there's like different things you can use, and there's all these tools, you know, kind of emerging that allows you to log this stuff. But capturing that data is very central to the evaluation.
Fantastic. I appreciate that context. And what it reminds me of as well is that, you know, when you move from traditional software to machine learning, you have to version a lot of different things, like not only code now, but models and data. And a lot of the data being generated now is, you know, natural language stuff. And this is part of the logging story, but it's also part of the versioning data story, right?
Yeah, you have to, and we'll talk about versioning also a bit later, but like you know, these data, you want to know what prompts they're associated with. You want to know what the code is associated with it. So the way that ML is, and the way that we're logging these things is like, you know, we know what commit is associated, like what code has been, especially for the unit test, which he'll get to in a moment. You know, we know what code is tied to what prompt and things like that. But there's more complexity to the versioning, which we'll get to.
I mean, there must be, right? Hey, we've got another great question from Marcus again. Is this logging and tracing interface in the database hosted, or can he use it on-prem also?
So Emil, correct me if I'm wrong, but like the Langchain allows you to specify an endpoint for its tracing, and you can send that tracing data anywhere, including Langsmith if you want. So like you could, in theory, like capture that data yourself and parse it, if you want to. So I mean that, you know, that I haven't tried that, but in theory it's possible, and we even discussed maybe doing it. So yeah, you could do that.
Awesome. So let's jump into unit tests now. What even are we testing? Why are we testing? What's happening here? And what are you using?
So
yeah,
what we realized early on is that, oh, sorry, Hamel. What we realized early on is that we have to be able to measure things, or nothing that we do makes any sense. Because it doesn't matter how well we fine tune if we can't actually tell how well it's functioning, or things are getting better. So unit testing, I don't know what it should be called, but it's just a matter of running tests against your model and seeing if how good it performs. Now, it's different from unit testing because when you work with a unit test, it's either failing or not failing in a software world. But in the language model world, obviously everything is not deterministic. So one time you run it, it works. One other time it may fail. So it's just a matter of running it in large numbers and taking a look at the aggregate number to see if things are improving or not. So what we realized is that we need to have a framework that we can run a lot of tests on every given functionality and look at the results in aggregate to see if things are getting better. Hamel, do you have something to add?
So let's jump in and have a look.
Yeah, okay, I can share my screen at this point, and then, you know, show you a little bit. So let me do that. Can you see my screen?
Yes, we can see GitLab.
Okay.
So just remind us
Yeah,
what
GitLab. So like
is.
instead of showing you my ID, I'm just being lazy and showing you the code in GitLab. But I could have showed you in VS Code too, but I'm just opening GitLab just because I don't want to switch around different applications. So okay, like basically if we go back here, when we have this, so we have this product with a lot of different features that Emil showed you. There's email, there's marketing, there's contact creation, there's all kinds of stuff. So within all of those features, there's many different scenarios. Like, okay, if you want to create marketing, but what happens if there isn't a listing in the database? Like, what if that listing doesn't exist? Or what if, there's many different kinds of scenarios. Like, what if you're trying to send an email or what if you're trying to do something with a contact that doesn't exist? Or, there's all these different scenarios that you want from a product perspective that you want the LLM to be able to handle. And when you're first starting out with LLMs, and by the way, this diagram, like the expectation is you don't have this diagram in day one. Like you kind of build this stuff up over time. So what you observe is when
And you
you
also
look
don't
at this.
necessarily recognize the entire diagram. Like when we were chatting about your workflows yesterday, like we kind of reverse engineered some of this from what you were telling me you were doing as well, right?
Yeah, it's always hard to come up with these diagrams. I mean, like I can come up with 10 versions of this, so it means it's hard to distill everything into a diagram. So, but yes, in this diagram will evolve over time. So just keep that in mind. So like you have all of these different sorry, let me go back here. Yeah, so you have all these different LLM invocations, and what you end up is like with a lot of failure modes. So like if I open Langsmith, when you're paging through this data
as well.
Oh yeah, let me zoom in. Okay, let me just make it bigger actually. This is weird. Oh, there you go. So basically like, so in Langsmith, you're paging through or whatever your logging system is. And by the way, we're going to tell you why we end up extracting our data from here. Is like you'll notice a lot of failure modes, like blank output or improper JSON or repeating something from the prompt that shouldn't be repeating or
But to be
emitting.
clear, and this is on the ChatGPT end, it's doing something weird.
Well, it doesn't have to be so like what do we care about? We care about what is this system saying to the user.
Yep.
Like whoever's fault it is. Maybe it's like our fault because like we have something funky going on in our system. Maybe it's the LLM's fault. We don't really know. What we want to test for is like, is it doing something stupid? And one thing I want to,
so just to be clear, this is when you type something into Lucy, like create a listing or send an email. It's the output or response to that.
Yes.
Testing whether that even makes sense or is blank or ill-formed.
Yeah, so as like a first order problem, you have all of these scenarios. Like this is the one, create a CMA for whatever. CMA is a comparative market analysis in real estate. And so like you want to see, okay, is this output, which this is JSON. So we don't have to get into the details, but does the output make sense? Like what is shown to the user, does it make sense? That is like the first order problem. And like when you're first starting out with LLMs, if you're looking at your data and like most of this workflow should be centered around looking at lots of data, like looking at data all the time. That is the differentiation between like things like the projects that go really well and projects that don't go well. Is like, are you looking at your data? So you want to like have tests for all these dumb failure modes. And that's like the first level of test that we have. And Emil has like, created a lot of these. I've written some of these. You can see I have like a commit here, which is funny. And like, notice like there's nothing fancy here. These are assertions. So basically you have assertions.
Could you zoom in as well?
And
yeah, while you do that, I'm going to do something cheeky, and I'm just going to share my screen briefly to show in the spirit of a very high level vision of another figure we can show is that with LLMs, with generative AI or machine learning modeling, we'll do a prompt or model something, then we'll explore or analyze data. And the reason I'm showing this is because, to Hamel's point, that a lot of what you're doing is looking at data and analyzing data. Then you perform some form of error correction. Then you go back to prompting or modeling again. So this is actually where Hamel and I started before kind of teasing out all the details with Emil of the figure that we're showing today and the process there. So I just wanted to show that because I thought that was relevant.
Yeah, that's a good maybe that's a better diagram in a way.
No, well, I think they're both incredibly useful, right? Depending what level of granularity you want.
Yeah, definitely. So I'm just showing assertions. So this is TypeScript.
Need to share your screen again because I kicked you.
Oh, you see him? Okay, sorry.
Yeah, I booted.
Let me go back. Let me go back. So, okay, like this is just, I'm just showing you, and this is like an example right here, no exposed user ID. And this is just like an assertion, because this is like one of the dumb failure modes we keep seeing over and over again. And there's many of these different kinds of things. So basically, doing simple things is a good idea in this process where possible. And one simple thing is have these failure modes, have assertions for those, test those. And so in this case, for Rechat, they have unit tests. And then every time that something changes with the code, they run the unit test against like an offline, kind of like a data set that tests for all of these different failure modes. And that's really big. That's really important. And so just as a side note, this is TypeScript, so you might not recognize it. It isn't like very interestingly, like even though like my whole career is dominated by Python, in the wild, like people building applications, there's a lot of, because of the nature of LLMs, there's a lot of TypeScript. And I found that, okay, I need to learn TypeScript or be comfortable, like just working in that. And like a lot of people like that are ML engineers are wanting to help people out with language models might hit this. And so, yeah, like, I just wanted to say that.
And I'm wondering Emil, I think it was you who originally chose to use TypeScript at Rechat, unless maybe you could just say a few words on the choice behind TypeScript.
Yeah, so there's two choices. One of them is, why did we use TypeScript for Rechat as a whole, which is a decision that we made years ago, and we were building just normal software, nothing to do with AI. We just like the ecosystem and the tooling and everything, which we are still very happy with. Like the tooling continues to improve and evolve. So that was a decision years ago. But when it came to Lucy and our AI, we were like, okay, there's a lot of tooling and a lot of big ecosystem around Python. Should we have a separate system based on Python, or should we continue investing in TypeScript for Lucy as well? Just for the sake of simplicity and not making our life too complicated, we decided to stick with the technology that we had because it allowed us to continue building on the infrastructure that we had. For example, the CI that you're seeing right now on the screen. This CI is very similar to the CI pipeline that we had for our functional tests and unit tests. And we had all the infrastructure in the world to create this very, very easily. Had we decided to separate our AI word into a Python word, then we couldn't have used any of the code that we had already built for our API internally. So we had to do a lot of work from scratch, which would have added to the timelines and added to the maintenance scope and whatnot. So it was a no-brainer for us to continue using TypeScript there, because the rest of the stack was. We did have this question mark on our head that, is this going to be a good idea? Are we going to regret this decision later? But so far, we've been very happy. There hasn't been anything in the TypeScript word that crippled us or limited us. But we managed to reuse all of the infrastructure and code and API that we already had built into the system. So that's been a good decision so far.
Fantastic. So now, in the interest of time, I'd love to move on to the evaluation and curation stuff, unless there was anything you wanted to add to.
Yeah, I'm just gonna say, like, okay, there's a CI. So these unit tests, they're running CI. And so that's what I'm showing here. This is GitLab CI.
That's continuous integration for those who
continuous integration. Yeah. So, every time, this is one kind of level of test, is like these failure modes, and you can see this is an example. Like in the marketing feature, there's a no listing found scenario, and then these are kind of the assertions that have been triggered, like empty responses, repetitive sentences, improperly formatted JSON. But you can see like we have all these different failure modes that we're tracking and testing. And then here, like you can, if you're kind of paying close attention and you're an ML engineer, you can see that we're uploading some of these statistics to weights and biases. But that's just kind of a temporary thing. We're actually building our own experiment tracking system, and Emil is actually building his own experiment tracking system, kind of geared towards LLMs. But we can talk about that later. So so let's move on. So you have your logging, your traces, you have your unit tests, you have some idea of like these failure modes, or at least the dumb failure modes. The next thing is like, okay, you have all this data, this logging and trace data. And kind of going back, just remind you what it looks like. So what you want to do is you want to be able to rapidly review this data, and you want to be able to like curate it. And you want to like be able to label which ones are good and bad. And you want to do that in a way that is like specific to you. So when I kind of came into the situation, Emil had Langsmith, and I was like painfully like basically looking through all of these records and click like to get out of this example, I had to like click on 10 things and get into another example, and it was hard to like navigate this data and look at this data. But then more importantly, like I wanted to be able to say, okay, this example is good, this example is bad. You have to have a way, you want to route the bad examples to the right place that can get worked on. You want to curate the good examples. You want to categorize them by the features so that you can then fine tune. And you can do a whole bunch of other things, like maybe train a reward model and things like that. So what we ended up doing...
Just very quickly, we have actually one clarification question from Stefan. I don't know if you know Stefan from Hamilton and Dagworks.
Oh, yeah. Okay. Yeah. Really nice guy.
He's an awesome dude. And he's asked a clarification question with respect to the CI test shown. It's all these tests are dependent on actual calls to the LLM API. So in that sense, they're actually integration tests, is his question.
Yes. Yep. Those are integration tests.
Yeah.
Yeah, at the moment, those are all integration tests. Awesome. So you're like running it all the way through.
Yeah.
And there's other unit tests and things inside the application, but I'm just showing you like the simple,
Thanks. We appreciate the clarifying question, Stefan. So sorry to interrupt you, Hamel, there. I just wanted
to... Yeah. Okay. You have all this data. You want to step through really fast, annotate it, debug it.
Let's get into the Shiny app.
Okay, you want to see the Shiny app?
Exactly.
So, okay, like we suck the data out. We suck the data out of Langsmith and put it into a database with a tool, with like a Python tool I created called Langfree, which is just a cheeky name about getting free of Langchain, but that's fine.
And you so created a wonderful logo for it as well.
Yeah. I created a parrot breaking free of chains.
Yeah.
Harrison is a really good sport about it, by the way. He's like, thinks it's hilarious.
They love your work as well, and they promote it. They're a huge fan of it.
So. Yeah. It's like a really so. Anyways, like, so this is kind of a recreation of Langsmith, but it is geared towards annotation. Like it's like so you can see it's like so what we have here is like a very similar view. You have the multi-turn conversation with like what the user said, and then you have a function call, you have function results, and then finally you have the LLM output. Now there's some very specific things here. One is, okay, I can like accept or reject a specific example. I can also see like, okay, in the things to do here, I can see like what scenarios that I have left to review, and I can see like which ones are how many I've approved. That's just very specific. I can filter. These are like basic things that we want to do that it's hard to like, if you take an off the shelf kind of tool that is like a data viewer, it may or may not have ways to do this. But then more important, like, and then like one interesting thing is we want to be able to edit the output. So like, this is the entire trace. And then at the very end of the trace, you have the final output. And we noticed for Rechat that often everything would be exactly correct, except there would be some small detail in the output that we don't like. So we would like, for example, this thing is right. So, but we would often see the sentence something like, let me know if you need anything else. That would be there. And then we would say, okay, we don't want that. We don't want like, just be like to the point. So we would actually like, and there's other like things that can happen. And we just want to be able to correct the output so we have ability to edit it and then accept it and say like, okay, we curate this data, but we can edit it. We made the trade-off here not to edit this stuff because at least right now, I don't trust myself to edit any of this other stuff because I feel like I'm going to make a mistake. But this, it seemed like the right trade-off for us to be able to edit the output. And then we can also see the functions. So like, these are the different functions that can be called. So this is the basic. So you can use anything. Like I would encourage people, don't get blocked. Whatever you do not get blocked by looking at data. Like do whatever you can, fight as hard as you can to make this as easy as possible. Like if you have to create tools to allow you to page through data really fast and annotate it really fast. And I'm not done with this. Like the next thing I'm going to add to this is like a semantic search. So if I see an interaction, I want to semantically search for similar interactions, for example. And there's all kinds of other things that I want.
Yo, Marcus in the chat says this is pretty slick. I guess it isn't open source, lol emoji. And of course, what you're showing
it is open source.
Well, exactly. This dashboard isn't open source, but it's built in Shiny for Python, which is all open source. And Shiny dashboards are actually incredibly easy to.
It's amazing.
Yeah, no,
I'm a really bad web developer.
Dashboard in several years, but when I worked in R a lot, I've actually never used Shiny for Python. But when I worked in R, building Shiny dashboards like kicked the ass out of so many tools for building dashboards in.
So Shiny is open source, but most of the components of this application are open source. Yeah. So like there's the cards in the so the data structure from Langchain that hydrates these cards. That's just like a simple component you can import from this library Langfree. We're not gonna get into Langfree because it's not a talk about Langfree, but as I open source as much of this as possible without exposing Rechat's code. So it is almost what you see here is basically open source, like with some exceptions.
Amazing. So Hamel, just timing wise, we've got around 15 minutes left. So I just want to make sure you're aware of that and how we.
Okay. All right. Okay, that what I showed you, even though it's like, so it's like looking at data, reviewing it, evaluating it is the most important thing you can do, and that drives so many things. Like that's like the center of this virtuous cycle, and basically, like when you step through as a human and you do these evaluations, that leads to a lot of things. One is when I look at data in this application. And, it's like I haven't reviewed this one yet. For example, it's pending. I might notice a new failure mode and like edit the unit tests. So I might, this leads to unit tests. This also allows us to curate data for fine tuning. So again, the thing that's driving this dashboard is a database. Like we suck the data out of Langsmith into a database. And this is like, driving that. And so when we make any annotations or any edits and we accept that, it pushes it back to the database. So
you're actually using Airtable, aren't you?
Yeah, so there's Airtable behind the scene. And that's a very pragmatic choice. For like what database we use, we try to make it super easy. First we like try to make this application itself in Airtable, and we're like, oh, that's kind of a little bit too much for Airtable. So then we kind of like organically moved to like put a better front end on top.
Well, and the reason I mentioned that, it isn't like you've got like a NoSQL database or something. Like it's something which, like this, is user friendly. You can jump in, look at stuff, play around with stuff.
Yeah, and then the thing is, like Emil was already using Airtable for so many things. So it's like, okay, I just use infrastructure that Airtable or that Rechat's already has, which is important. So anyways, like going back to this, when you do this creation, what we do is we save the data for fine tuning back to a database, like these accepted examples and these curated examples. and we use that for fine-tuning models. So right now, we are fine-tuning OpenAI models. However, that data is, is stored in the database. There's no reason why you couldn't fine-tune something else based on that. It's not necessarily like OpenAI specific. Like, we don't have to get into like the terms of service and licensing. That's like a whole crazy issue. We don't have to get into that. But the fact of the matter is that data can be used to fine tune any other model, because it is like instruction. It's basically a instruction tuning data set, because it's conversational. And that's the thing about this flywheel, is like you end up creating this data set over time. So that happens. And then also we do some prompt engineering. So we, from time to time, because we are, looking at lots of data, we say, okay, like, maybe we do some prompt engineering. And like another thing I'm going to add to this is the ability just to change something and add, and then like replay it. But I haven't gotten there yet. Is like just change one of these, edit one of these and then play it through the language, through the infrastructure to like see what happens. That's a little more complicated. Obviously, I haven't even thought about that yet, but like basically do prompt engineering. And so that is an interesting problem. So this is where like the experiment tracking comes in, and the database that Emil has built and is creating for experiment tracking is really important, because fine-tuning and prompt engineering live in direct tension with each other. So when Emil, myself, or anyone else changes some prompt in here, like for example, one prompt we want to get rid of, like we will get rid of, like is this thing right here. So this user thing is actually a prompt. It's like we inject this like prompt into the chain of like, please reformat this JSON to be in a code block. We are going to get rid of that. And we're going to get rid of that. Well, how are we going to get rid of it? We're going to fine tune. So the reason prompting lives in tension with that is like, once you remove this, you also want to remove it from your fine tuning data, because you don't want things in your fine tuning data that don't reflect don't reflect production. So these two things are being versioned. Let me go back to this. So there's prompt tuning, and it's like a virtuous cycle that goes back. And then basically the signals that we're capturing here, eventually you want to minimize, like you want to make this as automated as possible. So this eval, this like accept reject signals, and are these like these determinations of like how good these conversations are, can be used to train a reward model. The reward model can then, you can then track the correlation between the reward model and the human signal over time. And it doesn't necessarily even have to be a reward model. Like let's say you can use GPT-4, maybe. You can track the correlation between an Oracle model or reward model to the human evaluation. And you can do make a principled decision like, okay, if there's enough correlation, then you can do less human evaluation potentially. But you can make a principled decision about that.
But you just use an LLM and put a classifier head on it or something. Is that right?
Yeah, that's like for a reward model. Basically, reward model is basically like a classifier that gives you a signal. And then you could use a reward model for RLHF or something like that, but I'm not even thinking about that. That's like way like
future music.
First, we're just trying to make this work first. So we're not even getting into all of this stuff. That's why it's a dotted line. The one thing that is important is user feedback and A/B tests, but that's like in stage 2 of this project, is like you want to do A/B testing and like incorporate user feedback and live user feedback. But there's many different sources like that are things that can be that are involved in this evaluation and curation. I just want to mention that like how important this evaluation and creation step is. It drives so much of what can be done, and it gives you a foundation in this asset. So the last thing,
quickly,
how many?
We've got another question a great question from Kevin. Kevin has asked, would you be able to add an example JSON output as part of the prompt? He says he's pretty new to the world, but his understanding is that you can put example outputs that the assistant would write.
I think he's referring to prompt engineering.
Yeah.
Like basically like, hey, like you need to do this, and you need to output something like this.
Mm.
You know, like you need to output a list, or you need to output
Exactly.
JSON,
Or
or
JSON.
please make, yeah, or whatever. So like, yeah, that's what exactly this is. Now this is like we're putting that in the prompt,
Yeah.
and then
And
we
you can
could
use, we haven't talked about this, but you can use system prompts to do that.
yeah, we could put it in the system prompt. We played around with that. Emil can talk about that. He's been fiddling around with this very specific problem that's annoying. Um, you know, to be honest with you, like so fine tuning, you likely don't need this prompt at all, because if you continuously show an example of like producing JSON with in the right way that you want, like we just want it in code blocks, it's likely I can already see that it's like making a lot of progress towards that.
Yep.
And we're already having a lot of success with fine tuning, and we can talk about that. Actually, like we could let Emil talk about that. So we might as well just go there. I'm gonna put
We
something on
actually,
my
in the
screen.
interest of time, we've got a few minutes left. So Stefan actually has another great question about the CI pipeline. Stefan's asked, how often are you updating the CI pipeline? Is that a costly part of the loop, or is it generally pretty smooth? For example, update integration LM tests seems like it could be brittle if you're iterating quickly.
Emil, you want to comment on that?
Yeah, so we run it very, very often. Basically on every commit that we make, if it changes anything related to the AI, we rerun the pipeline. We do often update it, but because the idea is that, as Hamel mentioned, you don't build this and be done with them. They continuously impact each other, so you always have to improve those. So the moment we realize that there's a new failure mode, it's up to us to go add new assertions or add new test cases for those scenarios that may happen. So it is, we update that very, very often, and we run them even more often. It usually runs very cheaply for us. It's not a place that we invest too much on, and is not a cost drain. Effectively, it's cheap to run enough that justifies its returns.
Appreciate that a lot. So Hamel, I do want to go back to the diagram, if you will. And we've got a few minutes left. I want to talk about the synthetic data in a second, but before that, I just wanted to see if you wanted to say much more about the user feedback and A/B tests.
Yeah. So I mean, like, by the way, like you would want to do something a little bit different here based on your use case. We want to like go through your use case. So like this question about like, hey, like this integration test can be expensive. There's someone where it will be prohibitive, like the way we are doing it will be too prohibitively expensive for you. In the Rechat case, it's not. So it's like, just keep it simple, do it, it's fine. But anyways, like, okay, A/B tests. So the idea behind the mental model is iterate as fast as possible. And you know, in the beginning, when your language model when you're first developing, you're going to have a lot of dumb mistakes. So you don't need, you want to get it to a certain level, obviously, before you do A/B testing or even release it to your users. And you want like immediate feedback as much as possible. So if you can catch the dumb mistakes up front, that's always better. So that's why you want A/B tests as part of this eventually, but in the beginning, you know, you want like these unit tests and these like assertions of failures, but it's all like an integrated system, and you have to like think about, okay, when you want to do an A/B test, and like, you know, it depends like how long your A/B tests take and all that stuff. Like there's all kinds of factors, and we don't have to get into that. That's a whole podcast on its own, like thinking about A/B tests. I just want to mention, like, the reason it's there because it's important, you know, to ground whether or not this thing is working or not. Because you can do all these offline tests and you can say, oh, like I'm doing dumb errors, but you really want to know, like, okay, are your users happy? Is this actually working? Blah, blah, blah. So, I mean, you have to have A/B tests, but we're not going to get into that.
Yeah. But I like the idea of doing another live stream or podcast on A/B tests for generative AI at some point. So I would like to wrap up by what we've done here.
There's one thing. There's the results, the end results. Like what happened when we did this.
Yeah, sorry. Before
that,
with the LLM invocations we started off with were all human generated at this point. So I just wanted you to say a few words about, you know, how you can achieve more scale by actually using LLMs to generate
Yes.
input
Okay.
for LLMs, and how humans can be involved in that as well, because you don't want to just have a machine talking with itself
Yeah, sure.
ad
Yeah,
nauseum,
so
because
yeah.
the labyrinth has no sense.
Um,
So
um, let me actually let Emil talk about that, because he's the one that, yeah, he actually wrote the code for that. So it might be interesting to kind of just let him talk about that.
Yeah, sure. So effectively, what we started with was this process, but it was always initiated by our QA team, who would have actual conversations with Lucy, and they would report if it was good or not good. But this was not effective. We needed to get hundreds and hundreds of successful cases reviewed, but our QA teams are only humans, so there was a limit in terms of how much they could produce, how many good examples they could produce. So effectively, what we created was a sort of an infrastructure that helps us create synthetic cases. If I may share my screen so I can dive into this piece of code really quickly. So this is this is an example of a script that we have that writes synthetic cases for one of our tools. One of the capabilities is that it can write emails on your behalf. So you're an agent and say, hey, send an email to Hamel and let him know I'm going to be late, and Richard is going to compose that email and create that email and just give you a send button so you can send it. We created this this tiny script that goes through a different language model. It goes through GPT-4. This is not a production. This is something that we run on the side during development. And we ask it that, hey, you're an assistant to a real estate agent. Come up with 50 different cases of your boss asking you to send emails. And that would give us a lot of examples, and then we would actually run those examples against Lucy, our AI. So we would actually invoke Lucy, get the response we want, and then run all of the tests that we created on our CI pipeline, all the assertions that we had created. We reuse them here, so it automatically filtered out all the bad examples that we could detect they are bad examples, and all the good examples that it detects are collected into the database behind Lang3. So effectively, what we can do is either have our human team go and invoke Lucy and have conversations with it and send us for review, but we can also invoke this script, which in a matter of minutes would generate hundreds of cases, and all of those cases are vetted through our CI pipelines assertions and tests already. So they're all very good examples to a certain standard. So when the human gets and sits down to actually review them, a whole class of issues have already been filtered out, so they are not even being reviewed by the human. It's very effective.
Amazing. So Hamel,
you may want to share again.
Yeah, okay, I can share. So let me share my screen. So we just wanted to show maybe two visualizations. The experiment tracking system that ML is building is still a work in progress, but I'll let him talk about this screen. So this is Metabase, and I'll let him talk.
Yeah, so effectively, there are three different components here. One of them is the CI pipelines that we are running. Every time we run those pipelines, at the end, we upload all of the results into a Postgres database. This allows us to run all kind of different type of analytics that you see here. Then we use Metabase, the interface you're seeing here. Metabase is a business intelligence service. Effectively, what it does is that it connects to any Postgres database or any different type of database. MySQL, it can connect to basically all the databases out there. So it connects to your database, you give it a query, it runs that query, and then it can visualize the results of that query. It's the gist of what Metabase does. So we upload all of the results of our CI pipeline runs into a Postgres, and then we visualize that Postgres using Metabase here. And what you're seeing here is an example of us comparing two different runs of the very same data set on a commit, but if against two different models. One of them is the GPT 3.5 model by default, and another one on the right is the one that we fine-tuned through our data. What you're seeing here is that the green, the baseline green, is the success cases. And the important point here is the invalid placeholder, the blue one that you can see on the left. This is something that we fine-tuned against. So we wanted to resolve this issue that it was creating an invalid placeholder. I'm not going to get into the details of what that invalid placeholder error means, but effectively it's an error that we wanted to get rid of. So we went through hundreds of cases, synthetically generated a lot of cases, went through Langfree to evaluate those, curate those, and leave out bad examples. We fine-tuned the model, ran the CI pipeline again. The CI pipeline results were sent to a database, a Postgres database, and now we can visualize that and see that here the success rate has gone way up, and all of the invalid placeholders that we saw on the left are gone on the right. So on the fine-tuned model, we never had this issue again because we managed to fine-tune against.
And this highlights the
issue,
importance of the testing system, because when we fix this error, we actually increase this other error, and that's if you're just trying to do this without a system in place, then good luck. But you need some way of systematically testing, because that's what happens. You fix one thing, you might break another thing. So that's an example of how this works. And there's another example too, which I can let Emil talk about.
Yeah, this is another tool. So I displayed the capability at the beginning that you can ask it to find your listing. So you ask it, find me a 3-bedroom with this price criteria or whatnot. Sometimes it would give an empty response. And we didn't like that. We thought it should always be polite and say, hey, I couldn't find something, blah, blah, blah. So again, we ran a lot of synthetically generated cases. We curated all of those, reviewed all of those through Langfree. And then ran ran all of the CI pipelines against 2 different models, and we can clearly see that that particular issue is also completely gone. So we realized that we can pinpoint these issues, write assertions for them, fine-tune against them, evaluate the results like this, and just continue repeating the process.
Incredible. Well, thank you both so much for this walking us through this entire workflow and set of workflows, this virtuous cycle of getting your LLM invocations and evaluating, curating them, and then improving the model. I want to thank everyone for joining as well and sticking around, and for all the great questions. And I thought maybe I could just ask both of you as a final question. I mean, there was so much in here and so much richness and so much bleeding edge research in how to do this stuff as well, because it's so new. But for people who are getting started with this type of stuff today, what words of advice would you have for them?
Okay, I try to go first. I mean, would be... Sorry, go ahead.
Oh, go ahead.
Okay, so mine would be just keep it as simple as possible. Don't take on extreme complexity, either with infrastructure or tooling. And also really focus really hard on the iteration cycle, being able to iterate really, really fast. Set up that foundation. It's very tempting to kind of just jump in and just keep prompt engineering and fixing one problem at a time. But you can do that. You should do that in the very, very beginning. But you should really quickly think about set up tools for yourself that make your life, that save you time, because it really adds up.
Absolutely. Emil?
Yeah, same as Hamel, keep it simple. But one thing I always refer to is that what you're trying to do is a golden chain, because there are so many different pieces and they all need to have a lot of quality. But you don't have a single golden chain at the beginning, and maybe you don't even have some gold. All you have is some wood, but that's okay. You build a wooden chain, and slowly you can improve the pieces and replace the pieces. So as you mentioned, as an example, we are storing a lot of data in Airtable right now. That's not as scalable. That's not a very engineering thing to do. And I'm pretty much sure at some point we'll throw that out. But it allowed us to iterate quickly and remove that blocker at the time. So we can create a database and just add columns and whatnot and move forward. So later, maybe we'll come back and replace it. I'm pretty much sure that that's going to happen. But what was good enough was enough to get us on block so we can move to the rest of the chain. So iterate, and don't worry about hacking something that is not going to scale. Not necessarily everything needs to be scaled. Only things that need to be scalable, and that's not everything.
Exactly.
Yeah, we might replace a lot of this, to be honest. Even the Shiny app. I mean, because things change when you scale and things are different.
Exactly. Cool. Well, thank you both once again for your time and expertise, and for such a good time as well. And thank you once again, everyone, for joining.
Thank you.
Thank you for having us.
And